Hello everyone, we are IN Numbers. Today we are going to share the mission of IN Numbers in the project of inspection robot and some interesting results. As everyone sees in the picture, inspection robot can inspect, record, detect objects and events in the factory. For example, when it detects a human falling on the floor, it will alert automatically and notify the type of the problem and the location of the incident. In this case, IN Numbers' mission is to build a continuous auto-learning and involving AI models and architectures for the inspection robot, which can learn new objects and events by human labeling. There are two main approaches to build the architecture. The first one is bottom-up approach. In this approach, object detection is used first, and then event detection. Lastly, the abnormality detection. There are a lot of object detection methods, such as bounding box and object segmentation. And also object segmentation in the whole picture, which can also help us find the object that I haven't seen before, like traffic cone, dish cover, and the ladder. However, using bottom-up approach will meet many problems, such as meeting the things and events they haven't met before. For example, what happened when an orange apple classifier made a banana? It doesn't know banana before. In the abnormality inspection in the factory, there are already hundreds of objects in our model, but the cross might still not in it. Therefore, the model still rely heavily on the logic scale of high-quality label data to learn different situations. And we will need a lot of labeler to assess this. Hence, label data and personal management will be a problem. The third difficulty is that a large scale of data requires a strong support of GPU computing power in order to let the model learn and evolve fast. As a result, the heavy GPU server management and the task distribution will be serious issue too. An ideal architecture is letting humans to do large scale of labeling first, and then let the machine learn the label data. After that, the machine can pre-label the unlabeled data, and the human only need to fine-tune and modify it, which can save the time for human to label more data, and the model can learn more and better. So, it will be a human-machine virtual assistant architecture. IN Numbers' new product Label Hub is this kind of platform. So next, we are going to present how Label Hub works with top-down approach. In top-down approach, we don't need to mark the object in the photo. The only thing needed to be done is labeling the entire photo. It's normal or abnormal. We train an AI model that can find and mark the biggest difference between normality and the abnormality. Just like in this picture, the model finds that the ladder is the abnormal part, so it marks the ladder. This one, the clothes on the floor, or anything falls on the floor, including the man falling by the pathway, and even the untidy wire. We also try the combinations of bottom-up and top-down approaches. The first combination is bottom-up approach followed by the top-down approach. Many objects cannot be recognized through this method. Therefore, it is not a good way to detect abnormal objects and events. Conversely, when we use the combination of top-down approach followed by bottom-up approach, the results are significant. When we put the abnormal area into the boundary detection of objects, the model can draw the boundary of the abnormal part first, and then feedback to human to define and label it. Then, human can teach the model what the object is. Similarly, it can mark humans in different conditions that they haven't seen before. For instance, people climbing ladder. With the result of various abnormal human conditions, we can classify the dangerous level of the situations, and then let the model learn the different levels of danger. Building the AI model requires a lot of label data, so we'll need strong support of labeler, computing power, and AI model management. Before, all of these managements all depends on manpower. Therefore, our product label hub dedicated to make the management more efficient and automatic, including pre-labeling and auto-training. Through this human-machine mutual assistance, the learning of AI model can be faster. Besides using the AI architecture in the industry safety incident recognition, it is also applied in AOI defect detection, car detection, and the medical image detection. So this is the highlight of our result in this case. Thank you.